sequence. So a couple terms here. Arithmetic sequence, that means we're just listing the terms at this point. The difference between them is called the D. You can find that by just subtracting one term, subtracting the term prior to figure out what that common difference is, all right? And that common difference can be positive or negative. So deciding if you have one, you're literally going to see if you add to get from one term to the next and if it's consistent. So if I look at this first one, I'm going to say plus 4, plus 4, plus 4, plus 4. My common difference is 4 because 13 minus 9 equals 4. All right. If I look at this one, I have plus 3, plus 5, plus 7. While there is a pattern going on here, this is not an arithmetic. All right, and arithmetic is going to be the same exact pattern there, addition or subtracting. So this is not going to be an arithmetic series here or sequence. All right. So that's literally how you recognize it. Do I add to get from one term to the next? Do I add the same exact number to get from one term to the next? If that is yes, you have an arithmetic and your common difference is that number. All right. There are specific ways on finding your recursive. All right, write the recursive and the explicit formula for the arithmetic sequence and then find a sub 20, my 20th one. All right, so recursive formula is easy. We just need to figure out what the common difference is. And so I am going to just say, well, from 19 to 16, 16 to 13, and so on. If I were to figure out what that is, my common difference here is negative 3. All right, so this is going to be my common difference if that's what I'm looking for. Recursive is simple. So recursive formula says, well, if I want to find some specific term, I'm going to take the term in front of it and just add my common difference. If I say plus a negative 3, it's much easier to just do that, right? Minus 3. So this is my recursive formula. Recursive, all right? If I want to then find what's happening on any specific term, that's going to be my explicit formula, all right? Now, explicit formula is going to say, well, I'm going to start with 19 because that's where this series starts, all right? 19 doesn't add. That's my first term. So I don't actually add a negative 3 to my first term. I start with my second term and do that. So if I wanted to use my recursive, I would say, well, I'm going to take 19 and I am going to just do 1 negative 3, right? This would be the 2 negative 3s for the second term or third term and so on and so forth. And that's where we get that n minus 1, all right? I'm going to say to find any specific one, I'm going to take that common difference and I'm going to multiply it by 1 less than where I am. If I'm at n, I'm going to multiply it by n minus 1. All right, that's an arithmetic. That's always how this is going to work. You do want to simplify it, so you do want to distribute that negative 3. Right, and then you do want to, go ahead and add those up. Usually they put it in slope-intercept form because this ends up being just a linear equation. This would be my explicit formula. Explicit. It's always going to be first term plus n minus 1 times your common difference. All right? So it's always going to look like that. Always. If they want me to find a specific term, then I am going to use the explicit to do that. All right? So if I want to find a sub 20 then I would say, well, that's negative 3 times 20 plus 22. This is my 20th term. All right. Explicit formulas for these. Recursive formula, which means how do I go from one term to the next, right? Recursive means I have to have a term to get the next term. You literally just add the common difference. So your recursive is really simple when you have an arithmetic. You say, well, you take the term prior and you add that common difference. That's how you get from one to the next. If I want the explicit formula, then I am going to say, well, I need to take my starting term, whatever that is, and then I am going to subtract 1 from how many terms I want. and multiply by the common difference. Simplified, you're just going to distribute and solve, or you can do it this way where we're just a sub naught. This is simplified. This is the same thing. If I took my term in front of it and subtracted, it's the same thing there. So given the arithmetic sequence, we've gotten two terms here, and they want us to find these. And for this one, I am going to use these general when I find something like this. In this case, they didn't give me starting term. They actually just gave me two different terms. And so I'm going to use what I know to be true. So I have this b of 7 here, and I have this b of 3, and I can use this generalized. All right, so you think about this. If I am starting at 1, then I would say n minus 1, but here I'm actually starting at 3, right? I'm starting at 3. They didn't give me the first term, so I can actually use that term as my quote-unquote starting term. So if I have a b of 7, I can say, well, I can start with b of 3. That is then going to be where I am minus where I started times the common difference, because I've only multiplied from that term 4 times, right? From 3 to 7, I've only added that common difference 4 times. I haven't added it all the way back to 1. So I'm not going to say n minus 1 here, because I'm not starting at 1. Typically in your standard explicit formula, you start at 1. They didn't give me the first term or the common difference. They gave me 2 different terms. So I'm going to say, where am I? Where did I start? And so this is going to be where I am minus where I started times your common difference. That's how many times we've multiplied at this point, okay? And so now I'm going to do this a little bit differently to find my explicit formula. I'm going to plug in what they've given me. B of 7 is -6. B of 3 is 8. Now I'm going to say 7 minus 3. Those are the 2 terms they gave me, times D. And then I can figure out what my common difference is, which will give me my explicit formula, which will help me find a sub 20. Does that make sense? And so I'm going to subtract my 8, divide by my 4. So my common difference is going to be -7/2, right, when I reduce 14 over 4. Okay? And so now I can still start at 8, like my b sub 3. But now I'm going to come up with a formula based on starting from there. So I'm going to say, well, if I want to find any one of these, I'm going to start at 8. And now, remember, 8 is my 3rd term. So I'm not going to say n minus 1. I'm going to say n minus 3 to solve this. And I'm still going to use my common difference that I now know. Okay? And so when you start thinking about these, you have to think about where you're starting from. All right? If they give you the first term, just use your n minus 1, which is your standard explicit formula. But if they don't give you your first term, you may have to go a different route to figure out an explicit formula here. And so this one's going to look a little bit different. I'm going to distribute the same way. I'm going to say 8 plus, and we'll do a minus there because it's going to be -7 halves n plus 21 halves, right? You can combine these two. That's 16 and 21. So we have -7 halves n plus 37 halves. And that's what this guy is going to look like here. Okay? Where I started from is going to help me find that explicit formula. And so then if I wanted to find a specific term, I'm just going to plug a 20 in here. I'm just going to say, well, that's -7 halves times whatever term I'm looking for. In this case, they specifically said the 20th term plus 37 halves. And we're going to get a really big fraction there. 51.5 negative. All right. So if they give you the starting one, you can go straight to, okay, we're starting with our first term, n minus 1 times d. If they give you something else, you're going to have to back into finding what that common difference is and then set up a new one to actually find your explicit formula. All right, so I'm actually going to have you try one of these. arithmetic means. So the terms that are in between two terms are called the means, okay? So if you have the first term and the 10th term, right, you're going to have 8 means in between it. Does that make sense? So 1, you're going to have 8, and then the 10th term. That's how this is going to work, all right? And so to find that, you kind of need the common difference because you got to find those in between to figure out which one you're on. But they usually give you a starting and a finishing, and they tell you how many means are in between it. So in this case, they said we have 3 arithmetic means in between these. And so what you can do is you can just assume, we're just going to say, well, this guy is going to be the first one. If I have 3 in between, this one should be the 5th one, right? They gave me the first one. I have 2, 3, 4 in between. They gave me 3 means in between. A sub 2, A sub 3, A sub 4, which means this guy right here is A sub 5. That's going to change depending on how many they gave you, okay? So you can just assume the first one is A sub 1. Depending on how many they gave you, right? Then you have your last one, all right? So you're going to treat this the same way we did that other one. We have the 5th term and we have the 1st term. What we don't have is the common difference. We need the common difference to find the 2nd, 3rd, and 4th term, which is what we're looking for. And so I'm going to say, well, if I have A sub 5, that should be A sub 1 plus 5 minus 1, where I am and where I started, times my common difference, right? Make sense? I need that common difference to be able to find those missing means. You're going to do exactly what you did here. Plug it in. 7.3 should equal 1.7 plus 4 times D. Subtract and divide. You're going to get D equals 1.4. So if you subtract, you get 5.6 equals 4 times D. When you divide, that's 1.4. Okay? So your common difference here is 1.4. You can either find a recursive. If you're only finding 3 of them, I would just add, okay? I mean, you can set up the whole explicit formula, but if it doesn't ask you to do that and you're just finding 3 terms, I would literally just take the first one, add 1.4, that's number 2, add 1.4, that's number 3, and so on and so forth. So if I want to find A sub 2, I'm going to add 1.4 to him. That's going to be 3.1. A sub 3, I'm going to add 1.4 to this one. That's going to be 4.5. A sub 4, I'm going to add 1.4 to that one. That's going to be 5.9. Those are my 3 means, or my 3 numbers in between the ones they gave me. Okay? So you're literally just finding the common difference and then giving however many means you were looking for to begin with. But this is always going to be the same. This is where you are. This is where you started. And this is subtracting those sub numbers, okay? So where you are and where you started, and then the n minus 1 is really finish minus start, okay, of your sub numbers when you set this up. The difference between sequence and series is that you're adding them, all right? So in sequence, it's just a sequence of numbers. In series, you're putting addition signs in between them, and you're adding up those numbers. For arithmetic series, there are specific formulas to figure them out, okay? And this is our little Gauss formula, okay? So little Gauss, 1 to 100, 1 plus 2 plus 3 plus 4. That is an arithmetic series, a common difference of 1 for 100 terms, right? And so it will always work out this way. There are 2 things you can do to figure out your sum of your series. It depends on what you have as to how you're going to figure it out, okay? If you have your starting and your ending term, like little Gauss did, he knew he was starting at 1 and he was ending at 100, right? So if you have your starting and your ending term of the list of numbers you're adding up in their arithmetic, you're going to use this formula. You're going to say, how many terms am I adding? 1 to 100. I was adding 100 terms. Divide that by 2. What was my starting term? 1. What was my ending term? 100. And that's how you would figure out 1 plus 2 plus 3 plus 4 all the way to 100, right? 5,050 is hopefully what you get there, all right? Now, there are going to be times when you don't know your ending term. In that case, you're going to use your common difference. So it depends on what you've been given as to which one of these you're going to use. If you only know your starting term and your common difference, right, then you're going to say, well, how many terms am I adding up? And then I'm going to start with 2 times my first one, and then n minus d. So this is the other formula you're going to see. When you don't know your starting and ending term, but you know your starting term and your common difference, then you can add up however many terms in that series you want to add up using this one. All right? And so those are the 2 formulas you're going to use for a series that is arithmetic. So let's look at this. Evaluate the sum. All right? Evaluate the sum. So for this one, I am going to say, well, I know that I am adding up the numbers from 2 to 100. I know that I am going up by how many? What's my common difference here? 2, right? And so a couple things I don't know. I mean, hopefully you can figure it out logically, but let's say this is not an easy one to figure out logically. I really need to know how many terms I have, all right? Now, 2 to 100 by 2s, you can probably figure out how many terms you have, right? But let's say you don't know. Well, you can figure out which term this guy is. That will tell you how many terms you have, right? So if I say, well, my ending term is 100, I know I start with 2. I'm going to say n minus 1 because that's what I'm trying to figure out. How many terms am I adding up in this particular sequence? And I know my common difference is 2 because that's how I'm moving from one to the next. All right? So you can actually figure out how many terms you're talking about by just plugging it into your explicit. All right? This is an explicit, right? This is where I am, where I started, subtracting between, and common difference. And so I can figure out how many terms, and yes, it's going to be 50, right? When I do this out, I would say 100 equals 2 plus 2n minus 2. That cancels out. 100 divided by 2 is 50. So that one was probably easy to calculate, but if you didn't know that, this is how we're going to figure out how many terms we're talking about. So now I know how many terms I'm talking about. I know my starting term and my ending term. If I want to add all those numbers from 2 to 100 going up by 2, I would use the formula S of n. How many terms I have divided by 2, my first term plus my last term. And so I'm just going to plug in what I have. Number of terms, that is 50 over 2. My first term was 2, my last term was 100, all right? When you 102 divided by 2 times 50, you get 2,550. All right, that's what happens when you add 2 plus 4 plus 6 plus 8 all the way to 100. All right, just looking at this example, pay attention to your notation. They've given you a sub 1, that's your starting, S 100. What do you think that is? S 100. That's actually the summation of the first 100 terms, okay? So they've actually given you your summation there. So when you look at your summation formula, something like this, all right? They've actually given you your summation. That's 10,900. They've given you your n, 100 terms, right? And they've given you your starting term. All right. They want you to write an explicit formula, which you can. You need to solve for your whatever term you're on, right? Your last term, so that you can figure out your D. But you can actually write your explicit term from that one. All right. Find your last term, which is your 100th term, and then figure out your common difference to get your explicit formula. So Mr. and Miss King decided to pay off their mortgage early by adding an extra $25 to their $800 mortgage payment in January, and then increasing their additional payment by another $5 each successive month. All right. First, they want us to write an explicit simplified formula for the sequence. If the starting point was 800 plus the 25, my starting number is going to be 825, right? So we have 825, all right? They don't tell us how many months we're doing this, so we are just going to say n minus 1, because we're at this point, we don't know how many months. We do know that each successive month they added 5. That would be my common difference. That's what they're telling me there. Common difference, all right? So if I wanted to figure out a simplified explicit, then I would just simplify this. All right, so this is my explicit formula here. The next part of this says, find the amount paid in December of the second year and the total amount paid during those 2 years. So they want me to find how much did they pay the very last time after 2 years. We're just finding a specific term here. What was the 24th time they did this, right? If it's the end of 2 years, they started in January. They're really asking me in lots of words to find that, right? That's what they're asking me. So I'm going to do that. I'm going to say 5 times 24 plus 820, right? They ended up paying $940 on that last payment if they were adding 5 each time. They said, how much did they pay in the whole time? The whole time is going to be a summation formula, right? I have everything I need to do my summation, right? If I am summing up this, I need to know the number of payments they made, right? Over 2. I need to know their first payment and their last payment, and I have all of that, okay? So to find this, I'm literally going to plug in what I know. They did this 24 times. That's my N. Their first payment, I know that too, right? That was $825. Their last payment, I just calculated. That's $940. Over the 2 years, they paid this much in their mortgage if I calculate it. All right? So a word problem in something like this, they're literally giving you starting term or common difference. Like, you just have to look for those words without those words, right? Their first payment was this. They just gave you starting term. They added this each month. Or if they're paying off a debt, they subtracted this each month, right? That's your common difference. And so when you're looking at word problems, look for those keywords for them in the word problem. All right? Geometric versus arithmetic is you go from one term to the next by multiplying, okay? Multiplying. So arithmetic, you're adding to go from one to the other. Geometric, you are multiplying to go from one to the other. And in order to find the two, you divide. So take the second term, divide by the first. You'll figure out what term you are multiplying by. It is not called a common difference. That indicates subtraction. It's called a common ratio, okay? It's a common ratio. So if I want to find out, I'm just going to say to find the common ratio here, I would say the second term divided by the first term. That's going to give me a 4, right? It can be a fraction if you look at this next guy. You do have to make sure, though, that it works. So if I look at the next one, 9 divided by 4, we have a problem, right? So for this one, it's not working. Look at the next one. The reason it's called a ratio is equivalent ratios should equal the same thing when you get to the final. If I say negative 24 divided by 36, reduce it to figure out what's going on. If I look at the next two, 16 divided by negative 24, right? We're still going to get negative 2/3. All right. And so if you keep going, you're going to see that this one does work. This is a geometric with a common ratio. It has to be in common. All right. And so when you're looking at first, if they tell you it's geometric, you don't have to prove it. You can just take any two terms and divide. If they ask if it's geometric or tell you if it's geometric to do this, you need to make sure that it is indeed geometric by checking those. All right. You do have the same concept. Look at page 464. Recursive's easy. To go from one term to the next, you multiply. All right. Explicit looks a little bit different. All right. This is where you are. This is where your starting term, whether it be the third term or the first term. And then you're going to take that common ratio and raise it to a power. Why? Because I'm multiplying r times r times r times r. That is an exponent, right? That is r to a power. All right. And so you're just going to subtract where you are versus where you started to figure out what power you're using there. Write the recursive formula and the explicit. Well, to find either one of those, I need my r. If I divide, I'm going to say, well, I have 78 or 72 over 48. I'm going to get an r of 3/2 when I divide by 24. You get down to that. My r is 3/2. So if I want recursive is really easy. To get from one to the next, I'm going to take the one in front of it and I'm going to multiply by that 2/3. Explicit is just as simple, right? In this case, I'm going to start with the starting term because that's what they gave me. So I would say 48 times 2/3 to the n minus 1. All right? Recursive and this is the same concept as the other one. They are not starting at 1. They're starting at 3. Okay? So if I want to find this particular one, I'm going to say, well, 96 is my 7th term. 6 is my 3rd term. All right? And so that's going to be r to the 7 minus 3, or r to the 4th. Okay? So you don't want to just make the assumption that you are starting at 1. All right? You want to make sure that you know where you're starting and where you're ending so that you know how you're going to do this. You are going to have to take roots here to find this r. So if I divide, I'm going to get 16 is r to the 4th. R could be either positive or -2. All right. We look at both cases to see what happens. If they want a specific term, you have to consider that your r could be positive or negative, depending on what it is. There are two possibilities. You could get your starting term, and that would still be 3, whatever. But you would say, if I want to say a sub n there, then I'm going to have my starting one. You can do 6 there if you want to. And you could say positive 2 to the n minus 3. Or you could say -2 to the n minus 3. Those are going to give you two different things, right? And so you do have to consider when it's an even root that you could potentially have two possible r's there. And so they didn't give you enough information to tell you whether or not you're using one or the other. So you have to account for both of them. If this had been a cubed root, there's only one option. Or if it had just been, any odd power. But if it's an even power, you do want to think about the fact that you could have two potential r's there. All right. But other than that, it's the same as arithmetic. Geometric means the same thing. The mean is the number in between them. You do have to consider how many they gave you. In this case, they're only asking for 1. So you can assume that the first term is 10. We're missing the second term. That's what we're looking for. And then you can say, well, the third term then would be 50. Find your R the same way. You would say, I ended at 50. I started at 10. I did R to 3 minus 1, so we're going to say squared. Again, we're going to have 2 possibilities. All right, and so we have 2 possibilities for this. We could say, well, it could be 10 times the square root of 5, or it could be negative 10 times the square root of 5. One or the other. There are 2 possibilities for this particular mean because I had an even square there. You do need to memorize these, by the way. You need to memorize these formulas, the summation for arithmetic and the summation for geometric. There are 2 for both of them, depending on what you have, all right? If I just have my starting term and my R, then I'm going to use this right here. My starting term, 1 minus R to however many terms I'm adding up over 1 minus R. This is the one you probably use the most, I would guess. If I know my starting and ending term, right, but I don't know how many terms, you can still do it. First term, ending term times your R over the 1 minus R. Okay, so these are different. This is taking R to a power. This is multiplying R by your ending term. It just depends on what you have. If you know how many terms, but you don't know ending, you're going to use this one. If you know starting and ending, then you can go ahead and add the summation based on this. All right. They can give it you so in this case, you know your first term and your last term. Your R you can figure out by dividing. Okay. And so you can use your summation just based on your first and last term. For this one, I know how many terms, right? And I know my R and my starting term. So depending on what you have, this one you're going to calculate your R. All right, by dividing these 2. This one, I know that's the number of terms. That's my starting term. That's my R, okay? And so depending on how they give it to you is going to decide which one you use. If I know my starting and my ending term, I'm going to plug it into the starting term minus the ending term times my R. And in this case, my R is 1/3 over 1 minus my R. That's how I'm going to calculate this one because that's what I know, okay? For the other one, I'm actually going to use the other summation. I'm going to say I know my starting term. That's my 3/4, all right? I know my R. 1 minus my R is that 2. And I actually know how many terms. That's this guy right here. Over 1 minus my R. And actually, you need to do 8 there. We'll talk about that. Did they do that in there? We should have done 8. Why did I use 8 there, by the way? Why is this 8? Number of terms. Minus 3 plus 1. Yeah. Why do I add 1? geometric, all right? You're going to think of this one as the same way as the other. Is it converging or diverging as to whether or not you can solve it, okay? If your R absolute value is greater than or equal to 1, then it diverges. If your absolute value of your R is less than 1, meaning you have a fraction less than 1, then it's going to converge onto a specific number. So the first thing you have to figure out is it diverging or is it converging, all right? Because you're always, for all of these, you're moving to infinity. You'll notice we're going to infinity, and that means the same thing, infinity, all right? So I have to figure out what my R is. Is that absolute value bigger or smaller than 1? So if I look at this one, I can say, okay, the absolute value of this particular guy is smaller than 1, right? So this guy is going to go to a specific number. I can use this formula here. All right, I can plug it in. My starting term is this right here. Starting term is my a sub 1, 1 minus 0.9, okay? That's going to be what this is going towards. It's going to have an actual number here, all right? However, if I do not have an absolute value smaller than 1, it's going to go towards an infinity. All right, so it's going to be a divergent, meaning I'm going to keep going. E is what number? 2 point something, right? 2.718, whatever, right? It goes on forever. It's an infinite. But divided by 2, it's definitely going to be bigger than 1 because E is bigger than 1, yes? So this absolute value is greater than or equal to 1, which means this is divergent. And we will not have a number we can give. We cannot use this in that particular case, all right? Look at this last one, all right? What's going on here? What am I multiplying by? What is my R? Negative 1/2. Is the absolute value less than 1? Yes, the absolute value of negative 1/2 is less than 1. I can use this formula. My starting 1/2 is my a sub 1. 1 minus my negative 1/2. That's going to be what I'm moving towards. I can plug it in. So before you even decide if you can use this formula, you have to know what your R is. Pay attention to your R.